Hi, this is Brain. In this session, we will be talking about the counter function blocks. To start with, we have to make sure that our soft PLC is up and running. After that, we go straight to our network tree. From our network tree, you can see that we have two program blocks, the research status and prog1. Now let's go into prog1. We are taken into our programming workspace. Okay, so let's start with the counter blocks. If we search from our functions below, the counter doesn't appear in this first group, so click on the next button. Here it is. You see F2, that's counters. So we click on F2. Under F2, under counters, we actually have three counter functions. One is CTU, which is actually count up. F2 is actually CTD, that's count down. And F3, that's actually CTUD, that's count up and down. We work with CTU first. Click on the CTU F1 function key, and then let's find an empty space. Here it is. Let's give it a zoom. Here it is. Now we have our CTU counter block. CTU stands for counter up or count up function block. Before we proceed, let's look at the definition of the CTU counter function block. Okay, up counter function block stands for, in short, is actually CTU. The description states, for each cycle that a false to true transition occurs at the CU input while R is false, the CV output increments once, counting up from 0 and stopping at a maximum integer value of 32,767. The output is true when CV is greater than or equal to PV. When reset R is true, the counter value CV resets to 0 and the Boolean output Q is false. What does it mean? Okay, for every change in logic in the CU input from false to true, rising edge, that's actually a signal for the counter block to count 1 as long as R is false. The preset value or PV is actually the reference count of the counter block, such that Q will become true if the count value is greater than or equal to the preset count value. The CV is the current count value. That is, this is the current incremental count value that is ongoing. So these are actually the parameters of our count up function block. Let's demonstrate how it works. Let's go back to formation. Okay, so count up is actually a Boolean input. Let's define a Boolean variable. Let's call it in1. It's a Boolean variable. If you remember, this is the trigger to the count. A transition from false to true will be will be triggering the count block. the R knob is actually the reset knob. Under normal count condition, this should be false, and this will only be true if we need to reset the counter. So this is another Boolean input variable, which is into the PV. This is actually the preset value, wherein when the current count value equal to or greater than PV, you will have true in your output. So this is an integer variable. Well, let's call it N3 because it's still an input, but this time the data type is this is an integer variable. Q will actually be set to true when CV is equal to or greater than PV. So this is another Boolean variable, but since this is in the output side, so we call it out1, and this is a Boolean variable. And the last one is the CV. It's the count value, which is actually the current count value. Let's call it out2, but the data type is this should be an integer variable. Now we have defined the three inputs to our count up function block, which is the CU, the R, and the PV, and the two outputs, which is the Q and the CV. Let me go online. Okay, now we have, if you can see, the output is true. It's because 0 is equal to 0. That's why you have a true output. So let's say let's change this value to 5. Right. Okay. So we have changed the value to 5, and if you can see, out automatically changed to false. Now let's start our counter. Let's make it count. Well, the conditions for it to start counting are should be false. We have preset value of 5, and then every time we change this state in the CU input from false to true, the block will start counting it, and it will put the counted value into the CV. Okay, let's give it our first transition from false to true. False, make it true. Put it back to false. Now if you can see, there was one transition from false to true. It was counted and put into the CV output, which is stored in the out2 variable. Let's make another transition in the count up knob. Make it true. Well, if you can see, from false to true, the CV has now increased by 1. I put it back to false. Another true. Another, put it back to false. One more transition from false to true. That's already 4. Okay, now if you can see, this is 4 and this is 5. The block says that the logic of the block says that when CV is equal to or greater than PV, Q will become true. So we will be expecting Q to be true if given another transition from false to true in your CU input. Great. So if you can see, your Q now is true because your CV is equal to your PV. Just put it back to false. What happens if we continue counting? Okay, let's put in another pulse or change the state from false to true in your CU input? Well, it will just continue and keep on counting. If you can see now, CV is 6. How do we reset CV back to 0 and Q back to false? That is actually by making your reset variable or your reset input to true. There, we made this true. CV becomes 0, and then your Q became false. Okay, now we have demonstrated how to use your count up function block or your count up counter function block. Okay, now we proceed to demonstrating how to make use of our CTD counter block. Okay, now we select F2, that's for CTD, that's countdown counter block. We have CTD counter block. But before we proceed, let's go back to our description of how CTD counter block works. Okay, CTD or down counter function block. Let's just read the description of the function. It says, for each cycle that a false to true transition occurs at the CD input, while LD is false, the CV output decrements once. Counting down from PV and stopping at the minimum integer value of 32,768. The output is true when CV is less than or equal to 0. When LD is true, the counter value resets to PV and the bool output is false. Now, what does it mean? Okay, CD, the same with the count up counter function block. This transition from false to true will be a trigger to a countdown. Just remember, count down. Okay, transition from false to true in your CD input will be a trigger for one-step countdown. LD, this is the initial value of your CV since we're counting down. So what does it mean? When this LD is true, whatever is the value of PV, it will be loaded into CV. Means if CV is 0 and PV is 5, when LD is set to true, CV will be equal to PV. Your PV is the preset countdown value. So in our example, we'll be starting with 5. That means we'll be counting down from 5. Q is the output where it will become true when your CV is equal to or less than 0. CV is actually the current countdown value, which will be decreasing every transition of your CD from false to true. Okay, now let's go back to our demonstration. We define local variables. We have used up to n1, n2, n3. So we make this n4. Remember, this is a boolean type because this is for your CD. X will be let's say this is n5. This is gonna be this is load val the reset knob, so it's also boolean. Okay. Next we define this as in6. uh, this is actually the preset value, so this should be an integer data type. Okay, now your output, let's say this is going to be out3, and this is an output, it's a boolean type. Why? Because this can only be true or false if CV is equal to or less than PV. So it's boolean. The last one actually is we call this out4. That's the current countdown value, which is actually going to be an integer data type. Now let's go display real-time data. To start with, since this is a countdown, there has to be some preset value. We make this let's say 5. Okay, now it's 5. Like I said, to initialize your countdown value, we have to load the preset value into the count value. And how do we do that? We have to make this into true. We make LD true, and this 5 in PV should actually appear in your CV. There it is. So we just have initialized our countdown counter block. We initialize it by resetting LD from false to true. So we have loaded the value in PV into CV, and Q is now false. Now we will start the countdown. Now we will create a transition from false to true in your CD input, and we should be expecting your CV to decrease by 1. True. There it is. Your CV became 4. Let's make it again true. Your CV now is 3. Another transition, false to true. One more transition, false to true in your CD input. Now the value is 1. That's why your output now is true. We continue the transition from false to true in your CD input. Your CV keeps counting down. Lower than 0, it's now -1. And one more. There it is. Now if we want to reset this, we just have to make a transition in your LD from false to true. Okay, now after we have just made the LD false to true, we have reinitialized your counter down block, where it made PV equals to CV, and it reset your Q to false.